So there's some important features that will help you create your sign diagrams even without having your calculator to draw the function with. The first observation, well, the main observation actually is to do with the powers on the linear factors. So the first one is if you've got a linear factor with an odd power, so for example 2x minus 3, the power that is implied is 1, which is odd, or 3x minus 2 to the power of 3, which is odd. If your linear factor has an odd power, then it will cut the x-axis at that point, as in the function will actually cross the x-axis in some manner or another, where this is the x-axis and the diagonal line is the function. And when that happens, there's a sign change. Okay, so you can see that when the function crosses the x-axis, down here it's negative and up here it's positive, so there's a sign change around this point of intersection. Or here it's positive going to negative, so there's a sign change around that point where it intercepts the x-axis. So that's odd powers. If it's an even power, so for example 2x minus 3 to the power of 2 or 3x minus 2 to the power of 4, it's going to touch the x-axis. So this is where we see the repeated root. For example, up here in this second example up here, we've got a repeated root of x minus 1, and you can see that it is in fact only touching the x-axis. And that will be the case for any even power on a linear factor. If it's just touching the x-axis, there is no sign change, and we can confirm that here. The function is below the graph, below the x-axis to the left of that repeated root, and it is below the x-axis to the right of that repeated root. So there's no sign change. So you can use that when you're doing sign diagrams without your calculator, which may very well be something that would come up on the non-calculator part of a test. All right, so having a look at these examples down here. I'll have a look at this one first. First things first, draw your sign diagram directly underneath. It is significantly easier to work with a sign diagram when it's directly below the graph that you're working on. It needs arrows on both ends and it needs an X to show that it's the x-axis. Our points of interest are here at -2, 3 and 6. And we can see that the function is cutting the x-axis at all of those points, so they get the solid line. Notice that the line only sits above the sign diagram axis. It doesn't go all the way down. From there, we just look at the sections of the graph to the left of -2. So when x is less than -2, the graph is below the x-axis, so it gets a negative. Between -2 and 3, it's above the x-axis, so it gets a positive. Between 3 and 6, we're back below the x-axis, so it's a negative. And then when x is greater than 6, it's above the x-axis, so it gets a positive. And that's it. All right, having a look at this one, which you should recognize as a tan diagram of some description, a tan function. Again, we draw our sign diagram directly underneath it using a ruler and as arrows and an X. All right, so looking at our critical points here, we've got an axis intercept, we've got an asymptote, another axis intercept, and another asymptote. So they need to be marked. The axis intercept gets a solid line, -2 pi on 3. The asymptote gets a dashed line, and that is at -pi on 6. Then we've got another axis intercept at pi on 3, and another asymptote at, what's that, 5 pi on 6. And from there we just look at the regions above and below the x-axis. Here it's below the x-axis, so we get a negative. Here between negative 2 pi on 3 and negative pi on 6, it's above the x-axis, so it gets a positive. Again, below, so it gets a negative between the asymptote and the intercept, positive between the intercept and the asymptote, and negative past the asymptote. Fairly obviously, this pattern of intercepts and asymptotes is going to keep repeating, but we only need to draw the sign diagram just for the section of the graph that is shown, so on the domain that is shown.